Today we are going to discuss some examples on northwest corner method. Okay, so before that, firstly, how to construct the LPP, by using given transportation problem. So first example here, given that 2 and here from. Okay, so here D1, this is D1, D2, D3 and D4. Okay, and here given that supply, and here given that from S1, S2 and S3, so their demand is given. Okay, so here 19, 30, 50, 10 and 7. Then second is 70, 30, here 40, and then 69, supply is given the 9. Okay, and next is lastly 48, 70, 20 and then 18. So demand is given that for D1 is 5, D2 is 8, 7 and 14. Okay, so this is our given problem. Okay, this is our given problem in this way. So how to construct the LPP? Okay, question is construct the formulate this transportation as a LPP to as minimum to total transportation cost. Okay, so these are given. Okay, firstly here column is transportation data is given in this form. Okay, so here for first cell is this is x11, x12, then up to so on x1n. Okay, here number of rows are 3 and number of columns are 4. Okay, and here given that supply and demand are given. Okay, total number of supply and total number of demand here this all are demand is Bj. Okay, summation of Bj is equal to 5, 8, 13, then 20, 34. Okay, and this is also 7, 8, 16 plus 18 is 34. Okay, so total number of supply is equal to total number of demand. Okay, then how to formulate this LPP? So firstly formulating this LPP by minimum to total transportation cost. Okay, so total transportation cost is objective function is here minimized type. Okay, so therefore minimum z is equal to given this is x11, then this is x12, then this is x13 and this is x14. Okay, this is again x21, then x22, x23, then x24, and this is x31, x32, then x33 and x34. Okay, so minimum z is equal to take all this value in objective function. So 19x11 plus 30x12 plus 50x13 plus 10x14 plus 70x21, then 70x21 plus 30x22 plus 40x23 plus 60 x2 4, then plus 40 x31 plus 8 x32 plus 70 x33 plus 20 x34. Okay, this is our objective function, and subject to constraints are take constraint column wise and row wise. Okay, so for constraint coefficient of variables are take only 1. Okay, so therefore constraints are x11 plus x12 plus x1 here x13. Okay, x13 then plus x14 is equal to total number of supply are given 7. Okay, this is one constraint. Then second constraint is x21 plus x22 plus x23 plus x24 is equal to 9, total number of supply. This is a row wise constraint. Okay, row wise. Then here last one is x31 plus x32 plus x33 plus x34 is equal to 18. Okay, this is a row wise constraint. And then column wise is first x11 plus x21 plus x31 is equal to 5. Okay, in this way x11 plus x21 plus x31 is equal to 5. Then x12 plus x22 plus x32 is equal to 8 Then x13 plus x23 plus x33 is equal to 7. And last is x14 plus x24 plus x34 is equal to 14. This is a column wise. And all xij are greater equal 0. Okay, where I runs from 1 to 3. Number of rows are only 3, 1 2 3, and g are 1 2 3 4 number of columns. Okay, this is our LPP problem. Okay, if we given any transportation problem in this way, then we have to formulate LPP in this way. Take in objective function, these all values in objective function, and variables are x11 x2 x12 in this way. Okay, and in object constraint take the only coefficient of variables only take 1, and their RHS is take equal to 7 9 18, and this supply and demand. Okay, that is supply and demand take their RHS. Okay, then next problem we have to see northwest corner method. We have to find the feasible solution. Find the feasible solution. Find the example. Find initial basic feasible solution by northwest corner method, NWCM, northwest corner method. Okay, so to find the solution of northwest corner method, there here their algorithm is, here example is transportation problem, here from and to. Okay, here D1 D2 D3 and D4, and here S1 S2 and S3. This is above problem is take here. Okay, so their problem is 19 30 50 10, and here supply are given that supply is 7, here demand. Okay, so here is 70 30 40 60, then 9 then 40, 8, 70, 20 and 18, and their demand is given that 5, 8, 7 and 14. Okay, so algorithm of northwest corner is here. Northwest corner, starting with northwest corner to table and compare the supply of source S1 with demand of destination center D1. Okay, so before that, here total number of supply is equal to total number of demand. Okay, so here their summation, demand and supply, their summation is 7, 9, 16 plus 18 is 34, and 13, 7, 13 plus 7, 20 plus 14 is equal to 34. Here total number of supply is equal to total number of demand. Okay, here total supply is equal to total demand. Okay, this is a rim condition. Okay, now we have to starting northwest corner. Now we start northwest corner. Okay, so northwest corner is here. This is a northwest corner. Okay, so start with the northwest corner of table and compare the supply of source S1. This is S1, this is S2, and this is S3 supply. This is D1, this is D2. Okay, this is D3 and this is D4. Okay, and if D1 is less than S1, that is if the amount of required D1 is less than the number of units available at S1, then set X11 is equal to D1, that is allocate the first cell of northwest corner 1 cell. Okay, this is a 1 cell, first row, first column. This is 1 cell, allocate this is X11 is equal to D1, that is value of D1. When allocate D1, if D1 is less than S1, here supply is given that 7 and D1 is a 5. Okay, supply is a here supply is 7 and demand is 5, that is 5 is less than 7, therefore X11 is equal to D1. Therefore putting their value is here, allocate X11 is equal to 5. Okay, why taking this, their value is 5, that is demand, this value is less than this value. Okay, that is demand is D1 is less than S1, so set X11 is equal to 5, then deleting this row. Okay, then find the balance supply and demand process, then next process to cell 1, 2. Okay, that is deleting this column D1. Okay, so here supply is equal to 7 and demand is equal to 5, that is D1 is less than S1, therefore set X11 is equal to D1, that is allocate 5 units of demand to cost 19. Cost is here given that 19. Okay, and delete the column D1. Okay, when if D1 is less any demand is less than supply, then delete this row or column. If S1 is less than D1, suppose that here S1 is less than D1, then delete S1 and allocate the first corner value is S1. Okay, that is set X11 is equal to 7, and here if supply is less than demand. Okay, so deleting column, so therefore reduced table is, therefore the reduce table is after deleting column D1, here 2 and here from. Okay, so first column is deleted, so remaining D2, D3 and D4, and here supply. Okay, and here S1, S2 and S3, and lastly is demand. Okay, so here 90, sorry here 30 for D2 column, 30, 50, 10. So delete this column, deleting this column, or only for this is okay, taking only these values, then 30, 40, 60, then 8, 70 and 20, then demand is 8, 7, 14, and remaining here remaining 7 minus 5. Okay, demand is subtracting from supply, so 7 minus 5 is taking only, remaining only 2. Okay, and then 9 and 18 as it is. Okay, so again start from northwest corner is here, S1 and D2, intersection of S1 and D2, this is a northwest corner. So here total of supply is 2 remaining and demand is 8, so S1 is less than D1. Here supply is equal to, here supply is equal to 2 and demand is 8, therefore S1 is less than D2. Okay, so set x12 is equal to x1, this is a first row and second column, so x12 is equal to x1, and remove row S1. Okay, so their allocation is 2, and removing this row. Okay, therefore reduced table is, then next is reduced table is here, remaining table is lastly here 2 and this is from. Okay, so here D2, D3 and D4 as it is, so removing row S1, remaining only S2 and S3, take their value 30, 40, 60. Here supply is 9. Okay, and for x3 row 8, 70, 20, and their supply is 18. Okay, and lastly here demand. Okay, demand for D2 column, demand is remaining only 8 minus 2 is equal to 6. Okay, subtract this supply from this demand, 8. Okay, 8 minus 2 is equal to 6 remaining, then 7 and 14 as it is. Okay, again start northwest corner. Okay, northwest corner, here value is 30. Okay, number of here again 6 is less than 9, so allocate 6 and remove column D2. Okay, remove column D2. Okay, therefore here 6 is less than 9, and therefore set x22, this is second row, second column, value is set x2 is equal to D2, their value is 6. Okay, and remove column D2. Okay, so removing column D2, therefore reduced table is, again reduced table is this is 2 and this is from. Okay, so here remaining only D3 and D4 and here supply. Okay, and here S2 and S3 as it is. Okay, therefore here D3 value is 40, 60. Here number of supplies remaining only 9 minus 6 is equal to 3. Okay, then 8, 70, 20 and 18 as it is. sorry, here only 70 and 20 and 18 as it is. Okay, so D3 column 7 and 14 as it is. So here again start from this column, start from northwest corner, D3 S2, okay, 40. So now supply is here 3 and demand is 7. Supply is less than demand, so set here allocate supply 3, okay, and remove column this S2, removing column S2, okay, and here remaining only 7 minus 3 is equal to 4. Okay, so removing this table, removing this row, so only we have to remaining only here, remaining only the this table, okay, this table remaining only. And so here only 18 is less than 4 is less than 18, so set for this here 3 is remaining, 3 is taking, so removing this row is removing, so only one row and two columns are remaining. So therefore again by starting from this, okay, starting from this row, okay, or I am directly right here 3 is less than 7, and therefore set x2 3, second row third column is equal to 3, okay, and therefore remove s2 and therefore reduce table is this is 2, this is from, okay, this is D3 D4 and only here S3 and demand is S3 column is 70 20, demand is 7 minus 3 is equal to 4, here 4 and here 14 as it is, and their supply is 18. So again start from northwest corner, so this is 70, 4 is less than 18, so their value is putting 4, okay, and 18 minus 4 is equal to 14, and here take a 14 value, okay, this is taking a 40 value in this way. So deleting this row, remaining only one row and one column, so they put 14 is equal to 14, put their value is 14, and therefore taking this all above this problem, then if we taking this all problems, okay, so there lastly continuing this manner step by step away from northwest corner, with finally the value reached in southeast corner. Okay, lastly southeast corner is taking here this southwest corner. Okay, so after reducing all the transportation problem is continue in this way. Cells without the quantities allocated are put in the parenthesis and their respective value of the corresponding decision variable. Okay, so putting lastly all values, therefore the transportation table, therefore the transportation table with allocation, allocation means they are taking their values, okay, supply and demand. Okay, so setting cell x11 x2 x12 x21 in this way, okay, is given by here 2 and from. Okay, so this is d1 d2 d3 and d4, here s1 s2 and s3, so their values are 19 here given that 19, 30, 50, 10, then 70, 30, 40, 40 and 60. Here number of year supplier 7, 9, then S3 column 48, then 70 and 20, and here demand lastly. Here supply is 18, demand is 5, 8, 7 and 14. So for first column their allocation for 19 allocation is 5. Then for second table is for 30 D2S1 has value is allocation is 2. Okay, then next is again S2D2 is 6. Okay, S2D2 is here again allocation is 6. Then S2D2, then for 40 D3S2 is 40 for allocation is here allocation is then 3, 4 and here 3, then 4 and 14. Okay, so here you 1, 2, 3, 4, 5, 6 number of allocation. Therefore number of allocation lastly here number of allocation is equal to 6, and here number of rows is equal, number of rows are 3 rows and number of columns are 4. Okay, and here for this table number of allocations are in this table number of positive allocation is m plus n minus 1, where m is a number of columns and n is a number of rows. Okay, and minus 1. Therefore here m plus n minus 1. Okay, m plus n minus 1, that is this table number of allocations are 6, that is m plus n minus 1. Okay, here that is m is equal to number of rows and n is equal to number of columns. Okay, this is number of rows are 3, this is 4, 3 plus 4 7 minus 1 is equal to 6. Okay, and therefore this is our initial basic feasible solution, that is initial basic feasible solution obtained. Initial basic feasible solution is obtained. Okay, and that is therefore total cost is equal to, how to find their cost? Total cost is equal to take a value of occupied cell. Here first allocation is 19 into 5. Okay, 19 into 5 plus for second 30 into their allocation 2. Then next is 30 into 6 plus 30 into 6. Then here 40 into 3. Then 70 into 4. Then 20 into 14. Okay, so solve this. Their value is 90 into 5 is 95 plus 60 plus 180 plus 120. Okay, this is 120, then plus 280, and here also 280. So their value is 180, 120 is 360 plus 560 8 920 plus 920 plus 95 is here 100. Okay, their value 1000 remaining 15. Okay, in this way their value is this is our total cost, and this is the initial basic feasible solution of given transportation problem. In this way solve this transportation problem. Okay.